we looked at how we come up with the formula for volume of revolution, general volume of revolution. The volume is the integral from A, where you start, to B, where you end, of pi y squared dx. Alright? Now, A and B, in this case, are on the x-axis. Now, suppose we consider this circle here. Say this is our x-axis. And we form a sphere out of it. In other words, something like a ball, football or so. Now, what we want to do is to find out what is the volume of the sphere. I remember seeing that when I search for the volume of a sphere, if you search for it, what you will get is the volume of the sphere equal 4/3 pi r cubed. That's what they give for the volume. But we want to find out how to derive this formula for the volume of a sphere. So now, let's see where they get this formula from, how they come up with it. The radius of the circle is, say, from here to here, this is a radius. Now, in order for us to do the integration, we want to find out what y is. Remember, this is our x-axis, and we have our y-axis here. So, x-axis, y-axis. The question is, what is the formula for the circle? Let's see if we can think up how what the formula of the circle really is. Alright? This is the radius. Now, how can we get this radius here? Well, if we consider making a right angle triangle here, then the height is our y for this, and the width is our x. And if you consider Pythagoras theorem, r squared equal x squared plus y squared. See that? Where r is the hypotenuse, and the x and the y are the other two sides of that right angle triangle. If we transpose this for y, we would get y squared is equal to r squared minus x squared, and y equals the square root of r squared minus x squared, right? So let's put it in this formula. Volume is integral of pi y squared dx. So the volume is the integral of, now we can specify what our a is and what our b is, because the thing is, this is 0 right here. I'll go to the right. What we have here is a radius r. From 0 to the right is radius. From 0 to the left, so remember, 0 to the right, that's one radius. 0 to the left, that's another radius. But this is over the negative side of the x-axis, so let's call it negative r. Alright? So we start at negative r as the lower boundary and end at r as the upper boundary. So remember, you have to review your definite integration, or using integration to find areas, to remember what I'm talking about. Let's say lower and upper boundary. So we integrate from negative r to r of y squared dx. Well, what is y squared? Well, we had it here. y squared equal r squared minus x squared. So let's put that there. We have r squared minus x squared. This is y squared now. See here? Y squared. R squared minus x squared dx. Meaning that we integrating with respect to x. X is the variable here. Now, when we integrate r squared, since r squared is just a number, just a reminder of what you do when you integrate. This is the same as r squared x to the 0. Because remember, if we write the power of x, it will be x to the 0. R squared is r squared times 1. But 1 is the same as x to the 0. Alright? Minus x squared dx. And we're integrating from negative r to r. So when we integrate, what happens? What do we do? This is r squared, just a number, time x to the 0 plus 1, which is just 1. So is the power rule. You add 1 to the old power to get a new power, then divide by that new power. Alright? Minus x to the 2 plus 1. So it is x to the 3. 3 is the new power divided by the new power. And as we do indefinite integration, we draw the left and right brackets, and we have the boundaries to the right of the right bracket. Lower boundary at the bottom, upper boundary at the top, from negative r to r. So now, what do? We say this is equal to, we're going to substitute r for x. So we have r squared times r, the upper boundary, substitute for x, minus, and we have the x cubed. So it is r cubed substituted for x over 3. So you substitute the upper boundary here, minus, you repeat the substitution, but this time the lower boundary. So it's r squared times negative r. Alright? Minus negative r cubed. Negative r cubed over 3. Okay? So, here. Now remember, oh, the pi. I didn't write the pi, I just realized it. It's pi y squared dx. So it is pi, or we could even have the pi outside the integral sign as well. Remember that rule of integration? You have a number times a function is the same as the number. The integral of that is the same as the number times the integral of the function. So pi times all of this. So the pi is here times all of that. And you have, this is equal to pi times all of this, right? So pi will times everything here. So what you get here now is pi times. This would be r cubed minus r cubed over 3. Minus r squared times negative r is going to be negative r cubed minus negative, then negative r cubed is the same as negative times r. Negative r cubed is going to be negative. We have a minus negative, so it's a plus r cubed over 3. Alright? Pi times all of that. Now, r cubed here. If you open the bracket, you're going to get pi times r cubed. You open the round brackets. R cubed minus r cubed over 3 plus r cubed, then minus r cubed over 3, right? Equal pi by, now, r cubed plus r cubed. Let's put these two together. R cubed plus r cubed is 2r cubed. Then minus r cubed over 3 minus r cubed over 3 is minus 2 times r cubed over 3. So, what you get here is going to be pi times what? Now, we could factor out the 2 and say 2 pi times r cubed over 1 minus r cubed over 3. Now, this is 1 r cubed minus 1/3 r cubed. If we factor out the r cubed now, we get 2 r cubed times pi times 1 minus 1/3. What is 1 minus 1/3? 1 is the same as 3/3, right? Is the same as 3/3. 3/3 minus 1/3 gives you 2/3. So you have 2 times 2/3 r cubed pi. Now we could rearrange that to say 2 times 2 up top here is 4. Is 4 over 3 times, put the pi here, times r cubed. So that's the volume of a sphere 4/3 pi r cubed, gotten from using volume of revolution of a circle.